All right, welcome. Today we are diving deep into one of the absolute must-know tools for any C++ programmer. I'm talking about the super powerful and flexible STD vector. So let me ask you this. Have you ever set up an array, filled it with data, and then bam, you realize you need just one more spot? Ugh, it is the worst. It's that classic programming headache where that fixed size just brings everything to a screeching halt. And really, that's the fundamental issue with old-school C-style arrays. Don't get me wrong, they're simple, they're fast, but man, are they rigid. I mean, just look at the difference here. The old C array is like a block of concrete. You declare its size, and that's it. It's set in stone. But the vector, the vector is like water. It's fluid, it's dynamic. It can grow, it can shrink, whatever you need it to do. It's just the smarter, more modern way to handle collections of data. So, with that problem in mind, let's get properly acquainted with this modern solution. It's time to officially introduce the C++ vector. So what is it exactly? Well, the STD vector is a special container that comes from the C++ standard template library, or what you'll usually hear called the STL. And just like an array, it's a collection of values that you can get to using an index. But the keywords here are advanced and dynamic. Think of it as the souped-up, intelligent big brother to the plain old array. Here's a really good way to wrap your head around it. If you've ever used the C++ string class to handle a bunch of characters, you're actually already halfway there. A vector works in a very similar way. The big difference, and it's a game changer, is that a vector can hold any type you want: integers, floating point numbers, even your own custom objects. You name it. Okay, so the theory's cool and all, but how do we actually use this thing? Let's pop open the hood and look at the essential tools in the vector toolkit, the stuff you're going to be using all the time. First up, maybe the most basic but important tool you have, the size function. See, with a C array, you have to keep track of its size yourself, which can be a pain. But a vector? A vector always knows how big it is. You just call that size and boom, you get the exact number of elements it's holding. No guesswork, just a simple and reliable answer. And this is where the real magic happens. Need to add a new item to your list? Just use pushback, and the vector automatically makes room. Realize you need to get rid of the last item? Pop back takes care of it. And if you want to just wipe the slate clean and start over, clear empties the whole thing out for you. All that complex memory management stuff happens behind the scenes. It's amazing. And this is a huge deal, by the way. If you were stuck with a C array, you'd have to write all that logic yourself. You'd have to create a new, bigger array, copy every single element over, then remember to delete the old one. It's a ton of manual, error-prone work that vectors just do for you. Okay, so what about getting things out of the vector? Well, you've got a choice. You can use the .at function, which is the safe route. It double-checks to make sure the index you're asking for actually exists. Or you can use the familiar square brackets. Now, this way is faster because it skips that safety check, but it's also riskier. If you ask for an index that doesn't exist, your whole program could crash. It's that classic trade-off. Do you want safety or do you want raw speed? All right, we've got the basics down. Now let's level up and unlock some of the vector's more powerful features that give you some really precise control over your data. And the key to all this precision is a concept called iterators. Now, don't let the name scare you. You can just think of them as these special, smart pointers that know exactly how to navigate through a vector. They let you get to any element, insert new ones, or delete old ones from anywhere in the collection, not just the end. And using them to just loop through your vector is actually a pretty straightforward three-step dance. First, you grab an iterator that points to the very first element using the begin function. Then you just loop as long as that iterator hasn't reached the special end marker. And inside your loop, you use the little star operator, the asterisk, to get the actual value that the iterator is currently pointing to. That's it. Now, here is a super important performance tip. When you pass a vector to a function, the default way, called passing by value, makes a full copy of the entire vector. If your vector is huge, holding thousands of items, this is incredibly slow and wastes memory. The pro move is to pass it by reference. This doesn't make a copy at all. It just gives the function access to the original. It's way faster, way more efficient, and it's almost always the right way to do it. So, okay, we've talked a lot about how vectors work, but why does any of this really matter? Where do we actually see this stuff being used? Let's connect it to the real world and see these vectors in action. The truth is, vectors are absolutely everywhere. Think about an airline reservation system. Managing a list of passengers that's always changing, that's a perfect job for a vector. Or how about taking a sentence and splitting it up into a list of individual words? Yep, a vector of strings. Video games use them constantly to store lists of enemies, player inventory, map coordinates. And hey, if you ever get into competitive programming on sites like Kattis, trust me, vectors will become your best friend. So you see, the vector is so much more than just a resizable array. It's a powerful, efficient, and safe tool that handles all the tedious, low-level memory stuff for you, so you can focus on solving the real problem. It gives you the power to work with data that grows and shrinks and changes over time. So the only real question left is, now that you have this power, what are you going to build with it?